All right, this is your reactions of alkanes video. And in this video, you're going to learn the two different types of reactions that alkanes will undergo. And this is in a separate packet from your naming packet. So you should have received this from me in class. You guys might remember that alkanes are hydrocarbons. So they contain all single bonds, carbon and hydrogen only. And generally speaking, they're pretty unreactive. They do, however, undergo two major types of reactions. The first one you learned last year, where they are fuels and they undergo combustion reactions. The second type is a reaction with halogens. Now, in this first type of reaction, combustion reactions, you guys know that there are two types of combustion. I hope you remember this from last year. So there's complete combustion and there's incomplete combustion. Complete combustion occurs when you have more than enough oxygen to adequately burn the fuel. And when that happens, your products will always be carbon dioxide and water. Now, you can write a balanced chemical reaction for octane. And I suggest right now just quickly pausing this video and seeing if you can do this on your own. And then turning it on to check your work. Okay, if you check your video or check your work, this should be the right answer. So hopefully you got that correct. Now, in the next problem, we're going to look at incomplete combustion. Now, incomplete combustion means you're running out of oxygen. This would be done when you have a poorly ventilated room, for example. And what you get are dangerous products. So you do get some CO2 and H2O, usually, but sometimes you will also get carbon soot. So that's like the black stuff you see after you've burned a match. And most dangerous of the products is the carbon monoxide. Now, writing a balanced reaction for the incomplete combustion of octane isn't as easy as writing it for a complete combustion because there are several possible acceptable reactions. But we're just going to write a fairly simple one. So if we have octane again, and we're going to burn it in oxygen, and let's just keep the reaction relatively simple by just assuming that instead of CO2 and H2O, we're going to get CO and H2O. And like I said, there are other variations of this reaction as well. And you could probably do some research to find them, but this is one possibility. Now, in this case, if you were going to balance this, the coefficients would end up being 2 and 17 and 16 and 18. So hopefully you can understand complete combustion and incomplete combustion. And really the way I've seen this asked on the IB exams is they want you to be able to name the products of incomplete combustion and state why they are dangerous. So for example, the reason carbon monoxide is dangerous is obviously because it's poisonous and can kill you. Carbon, the soot, the carbon solid is dangerous because any particulate, any solid that gets into your lung is not safe for your health. It's like breathing in secondhand smoke. You don't want particulates into your lungs. So that's usually, I've seen that asked on IB exams. Now, there is a second type of reaction for for alkanes, and that's reacting with halogens. But this will only occur if there's UV light present. Now, you might remember last year we studied the electromagnetic spectrum, and UV is at the it's on the far end, the high energy end of visible light. Now, here's an example where we have methane, CH4, reacting with chlorine, Cl2. And if it's got UV light present, which a lot of times will be indicated by writing it right over the arrow, then what you can get to happen is a chlorine can take the place of one of the hydrogens, and so you get CH3Cl, and then that H that got kicked out will bond up with the other chlorine, so the other product is HCl. Now, there's a mechanism by which this occurs, and it's called free radical substitution. Now, a free radical is just an element, any element, or compound for that matter, that has one single unpaired electron. Now, hopefully you know enough chemistry at this point in the game that you understand that electrons like to be paired. They do not like to be single like that. Electrons try hard to find pairs. And so this free radical is extremely reactive because it's trying to find an electron to pair up with. Now, if we look at possible starting points, those are called the initiation steps of the reaction. So how does a free radical even get formed to begin with? Well, one possible way is for that UV light, which is high energy, to break up the halogen homolytically to make a free radical. So using this, my computer's being slow, you can see this reaction here, but if I draw this out, it might make more sense. So if you think of chlorine, each with 7 valence electrons, we understand, and I'm going to draw the second one as a different color, we understand that they really do like being paired up. That's why they're diatomic elements. But when UV light shines on that bond, it's going to break up the bond, and they're going to split homolytically into 2 free radicals. Well, those free radicals are going to go and do some damage. So what can they do to keep this reaction going? Well, these are just possible propagation steps. So the propagation steps don't necessarily happen in order. These are just possible steps that could happen to keep this reaction going, because the reaction will continue to go as long as there's a free radical around. So you're going to see here 2 possible propagation steps. You'll notice we have a free radical reacting with the methane here. And what that does is it rips one of the H's off of the methane and brings it over to the Cl. And we still have HCl formed, but it's still a free radical. That's going to make it dangerous, and that's going to keep happening to make the reaction keep going. Another possible propagation step is that this methane was the free radical that was created. So instead of this originally splitting up, the methane, a bond in the methane would have gotten attacked. So let's say that guy would have gotten attacked, and 1 electron went here and 1 went there. So the methane free radical, the CH3 free radical, is going to now bond up with a Cl and create another Cl free radical. These are just possible propagation steps. There are probably others as well. Now, the only way for the reaction to eventually stop is for the free radicals to be stopped. So the only way free radicals can stop being free radicals is to find a partner, another free radical. So in these 2 possible propagation steps, actually I've got 3 for you, you're going to see that there are possible, when they pair up, you know, they finally become stable. Okay. Now, it does say if there's enough chlorine present and you get enough free radicals to happen, you don't necessarily just get monosubstitution, meaning 1 chlorine would add on to the CH groups. You could add even 2 or 3 or even fluorochlorine. So something like this, where there are 2 H's and 2 Cl's is possible, or 3 Cl's, or even 4. So that's the those are the reactions of alkanes.